Chapter 6, Section 1, we are moving on to systems of equations, so no more inequalities for now. Going back to equations would mean things are going to be equal on both sides. But a system of equations are two or more equations, basically, that are working together. Okay, so they're related somehow, they're working together. And basically, you're looking for where they're either the same or something like that. So when you have systems of equations, you solve systems of equations, you have three possible answer options. One answer, which would be when you graph the two lines, the point where they meet, and we call that consistent and independent. Okay, so it's consistent because there's a solution, and it's independent because they only have one thing in common. Infinite solutions, which means their two lines are graphed over top of each other, so what you can't see is the red one is also right here, like they're right on top of each other. Okay, so they're basically the same line, and what that means is they're consistent because there's an answer, but they're dependent because they're dependent on each other. They completely rely on whatever one is, the other is also, so they're completely dependent on each other. And then the last one would be no solutions. So this would be two lines that run parallel to each other, like this. Okay, so if two lines are going to run parallel to each other, they're never going to meet. They're never going to intersect, which means they're never going to have a solution because there's no point in time where these will ever be the same. And we call that being inconsistent. Okay? So if we look at example 1, it says use the graph at the right to determine whether each system, so we're just looking at A right now, determine if the system is consistent, inconsistent, and if it's independent or dependent. Okay? So if I look at A, I'm going to graph both of these lines. Okay, so I'm going to graph this one in red, and I'll graph this one in blue. Okay? So for my red line, my slope is going to be right here, so it's negative 2 over 1. And my B value is going to be 3. Okay, so again, this is just review. Nothing new here. And then for my blue graph, my slope is the number hiding in front of x right there is a 1. So 1 over 1. And then my B is going to be at negative 5. So I'm going to graph both of these lines. So I'm going to start with the blue one. 1, 2, 3, 4, 5. I put my point at the y-intercept of negative 5. You graph your slope, which is up 1 over 1, up 1, up right, up right, up right. And you just keep going. And then you'll connect your line for your graph. Okay? So there's your first one. Then go graph the other one on here. And it's at 3 is my y-intercept. So we're up 1, 2, 3. Put a point. And this slope is at negative 2, 1. So I'm going to come down 2, right 1, down 2, right 1, down 2, right 1. Okay? And then you will connect those points. Okay? And we have right here 1 point of intersection. They intersect at 1 point. So they are going to be this situation here. They have exactly one solution. So they are consistent and they are independent. So they can be solved. But they only have one answer that is correct for them all. All right? Okay, so try 1A and 1B, and then check back with me. Okay, so for 1A and 1B, they both came out to be consistent and independent. So for 1A, my red line here, we started at my y-intercept of 3, and my slope was rise 2, and I went backwards down to left 1, down to left, down to left, down to left, okay? Then I repeated this process, so I went to negative 5 for my blue line, and I knew I had to come to the left, so I only did my slope in that direction because that's the way I had to go if I was going to get them to meet. So I went up 2 and left 1 to get my negative there, up 2 left to get the negative. All right, and you can see they meet in one spot, so they are consistent and independent. Same over here with 1b. My y-intercept for both of these was at -5. So that should have been a key indication, them having the same y-intercept but different slopes. Okay, so you should have been able to tell right away, well, they're definitely going to meet at one point because they have the same y-intercept. But they had different slopes, so they weren't going to be this line here, because if they have different slopes, that means they're not the exact same line. They're not going to be directly over top of each other. So that means it had to be this option. We could have figured that one out without even graphing them, but we did anyways, just to be extra sure. Okay? So if we look at example 2. For example 2, it says graph each system and determine the number of solutions it has. If it has one solution, name it. Okay, so they don't only want you to tell me, does it have one, infinite, or no solutions? It wants you to tell me what that solution is if it has one. Okay, so I'm going to graph this one in purple, and that one's slope is here, so -3/1, and the y-intercept there is 10. So I'm going to go up 10, which is my very top point, and then my slope is -3/1. So I'm going to come down 3 to the right 1, down 3 to the right 1, all the way until I run out of graph. Then I will connect those points. All right, I'll graph this one here and we'll do red. Okay, so this one has a slope of 1/1 from right here, and my b is at -2. So I'm going to go start with b, then I come up 1 over, up 1 over, 1 over. Okay, so I found the point of intersection, so I can stop graphing now. So they have one solution. All right, and it is at the point 2, 3, 1. Okay, and I got that because that's where they intersect at. All right. Okay, try B and then see what you get. Okay, so for B, when you graphed these, before you could go graph them, you needed to solve them and get them into that y equals mx plus b form. So I subtracted 2x from both sides here to get -y, and then I divided by -1 to get rid of that, leaving me with y is equal to 2x plus 1. So you change the sign of everything when you divide by -1. That left me with a slope of 2 and a y-intercept of 1. So I graphed my y-intercept. Ooh, I did this slope wrong. I did that slope wrong. So let me fix that real quick. So my y-intercept is at 1, and my slope is 2/1. Down 2/1, down 2. Okay, so there's that one. All right, that's better. And then I did the same thing over here. Again, I had to solve for y first, so I subtracted my 4x. Then I divided both sides by -2 to get y is equal to 2x minus 3. So again, my slope is 2/1, and my b is -3. All right, so this means we have to go back a little bit. You have to remember what it means when two lines have the same slope. That means that they're parallel. Okay, so if two lines are parallel, that's when they have the same slope, okay? If two lines are parallel, they're never going to meet. They're never going to intersect, so they're not going to have any solution. So there is no solution on B. That is your answer. No solution, okay? Because these two lines are never going to intersect with each other if I drew them perfectly straight, which I didn't because I don't have a straight edge on my tablet. But you get the idea. Okay, so let's look, and then here we have our example 3, our last example, and this is number of girls participating in a high school soccer, track and field has steadily increased over the past few years. So we're going to use the information in the table to predict the approximate year when the girls participating in these two sports will be the same. Okay, so basically we're going to graph them each. All right. So to do that, you need to start by basically you need to find the slope for each one, right? So we need to find the slope for soccer, and we need to find the slope for track and field. All right, so let's do that. For soccer, so I'm going to find my slope. My years right here are going to be my x values. Okay, because if I put these on a table, which I'm going to end up doing, I'm going to graph them. Time goes across the bottom, so years is going to go down here. And then members will go up here, so students will go there. All right, so I'm going to take 371 minus 345, because those are my y values, over my x values, which is 2012 minus 2007. Okay, so that's going to be my slope. That gives me about 5.2. Okay, we're using a real world situation, so, decimals are fine because nothing in real life works out perfect ever. So then we're going to try and we're going to do the same thing for track and field. Okay, so I'm going to find the slope there is going to be 467 minus 458 over 2012 minus 2007. Right? And that'll give you about 1.8 when you solve it. Okay. So we're using since 2007. So this is kind of like our starting point. This is like our year 0. That's a lie. That's a lie. We're going to look from 2012 on, right? We don't really care about, we know they haven't been the same yet to this point. So really what we're doing is we're looking from 2012 on. So 2012, that's going to be our starting point, okay? Which means it's also going to be our y-intercept. If it's our starting point, it's at year 0. So that's our y-intercept, okay? So for my purple line, I have my m, and my b is going to be 371. For my red line, my b is going to be 467. All right. Then you're going to graph these. Okay, so you're going to put them on a coordinate plane and graph them. Are you going to get exactly the right number? Well, technically, yes. You're going to be able to read it very easily. Maybe, maybe not. So you're going to want to do some checking here to make sure you're getting the correct answer. So what you'll do, okay, is you're going to graph. But you need to, before you can graph, make your plane. So when you do this, I'm going to put a break in my graph so I have enough space. Okay, and I'm going to count by 50s, but I'm going to start at 300. So I'm going to go 300, and then 400. I'm skipping a line because I'm actually counting by 50s. 500, 600, and then 700. Okay, then I'm going to do the same thing over here, but this time I'm just going to count. I don't need a break in my graph. Okay, I'm just gonna roll with this. It's going to be 5, 10, 15, all the way over 35, 40, 45. Okay. So 371 is going to be between 350 and 400. So my purple one is going to go right there. And then you're going to go up and over, up and over, up and over. Okay. Then you're going to do the same thing with 467. And the reason why I'm not continuing to graph this is because you're not going to be able to read it, are you? Which is where you need your calculator. Okay? You need to learn how to graph using the y equals function on your calculator. Okay? I'll post a second video after this showing you how to do that. But a problem like this, you're going to look for the intersection on a calculator. Okay? Look for the intersection. Because you can graph this over and over and over and over and over again, and you won't get the correct answer because you're just going to be estimating. So you need a calculator to do it. Or you could just wait a couple weeks and we'll see how to do it without a calculator. That'll work too. Hint, hint. But anyways, here's your homework. 25 and 26 you will need a calculator for. Okay?